We're very, very grateful for what people are building, especially in the compute and data storage space. This is going to be fundamental. We are at the beginning of what could be a revolution in how knowledge is produced, disseminated, accessed, and verified. The Desci movement, for those of you who have not heard about it, is a nascent movement that seeks to find new ways to fund, to publish, to access science, and essentially to amend the flaws of the current system where it has failed scientists and scientific communities. What we're building is essentially a vision for the scientific record. It's a vision where the scientific record becomes an unstoppable repository that is universally accessible to all. And this requires building on this phenomenal decentralized stack that has been created by communities like yours. I can give you a number of examples in my life where who here has published a paper? Raise your hands. Great. So some of you are familiar with the publication process. There's tremendous issues in science when it comes to scientific publishing. First of all, the entire architecture is, we could call it obsolete, where we rely on these solitary PDFs. We give very little credit for publishing code and data. Science is essentially something you need to trust from the paper that you read. It shouldn't be this way. It should be something you can verify. Moreover, the publishing industry is essentially oligopolistically controlled. Scientists need to pay to write on the scientific record. They need to pay to read on the scientific record. Publication fees, ranging from $2,000 to $10,000, depending on the prestige of the journals you wish to publish in. It shouldn't be this way. So what we're building at Desci Labs is essentially an integrated stack to allow scientists to publish their work, not just as PDFs, like you do on arXiv, but also combine that with data, with code, with all the digital artifacts that allow to make your work reproducible bottom up. And we want to do this, we want to create that stack in the most open and permissionless way possible, so that it's not stored on some centralized silo that's running on AWS, but rather it is indexed on a ledger that indexes these research objects in a way that make them universally accessible and unstoppably accessible. So let me give you a little demo of what we've built so far, just to get some concrete example of what this experience could feel like. So here I'm taking, this is a typical page where scientists would go look up for information. NIH website. What do scientists want to do when they come on such a website, or any website, publisher's website, IEEE, anything? They want to just go to the PDF. They're like, please, I'm not interested in looking at all of the things you have on that website. So that's where to go. And this is the type of experience, scientists feel good in. It's like, okay, now I can read. I'm straight at the information I want to get. And people can go through the paper and essentially explore the findings that are presented inside. So what we've created is essentially a system where you can link your research, your publications, to all of the artifacts that are essential to the scientific record and to reproducing your work. So we have here in this paper, for example, an embedding that you can see. Click to access. So what will this do? This is going to essentially resolve a decentralized persistent identifier that is protected against constant drift and allows you to access the entire linked data structure of that research object in an IPLD Merkle DAG structure. So we resolved that with a resolver that we call Desci. Tell you more about it. We're greeted by AI-generated art because, let's make science beautiful. We now have the tools to do it. You can go through this paper, you can explore it, and you're in an experience that's familiar to you. But what else do we have? Well, we have the possibility to access extraordinary richness linked to that specific research object. So as you can see here, you have information about attributes of that published research, the validation path it has taken, components that are linked to that research. For example, scientists produce a wealth of research output, but yet we only publish PDFs in the majority of the case. And that's a tragedy for the scientific record. What we have here is the ability to add a reproducible notebook, to add supplementary materials, to add data, to add slide decks, to add video, to add any type of hypermedia information into that object directly in that interface, all stored on decentralized storage. I can also add annotations. I can enrich my work and give it some context. I can have social participation. One of the features we're particularly interested in is linking this with decentralized compute. So what we have here is a figure of this paper showing, some spectral analysis. Well, I can now click, reproduce figure 1. And I'm in a coding IDE. I have a VS Code integration. And in this case, it's a Jupyter notebook. I can re-execute these figures from the source to regenerate them directly into these PDFs. And I can do this without fundamentally changing the workflow of scientists. I'm not saying, we should all publish, HTML objects with embeddings. No. You can push to Desci nodes, or you will be able to push from Overleaf directly. Connect your data, your code, all of it, and make it simple, make it reproducible, allow others to explore how to recreate your work from source. So as you can see here, Jupyter Notebook is executing, it's reproducing those results. And we're super excited about the prospects of allowing to combine this type of interfaces with Bacalhau and other compute solutions. And something that's very important for us is user experience. We want to make it simple for scientists to be able to say, hey, look, my work reproduces. You can connect easily these containers, these notebooks, your code, to make your work interactive and to allow others to not only understand your results, but perhaps vary the parameters of your model and explore it and understand how they can do it themselves. So this is something that's now possible. We have the technology to essentially make scientific work rich and reproducible. You can add supplementary information, data. We have capacity for storing extraordinarily large data sets on the Filecoin network at not even a fraction of the cost. It's essentially free. As we know right now, it's not going to stay free forever. But that's an extraordinary opportunity to allow for reuse of scientific artifacts in the entire scientific community. So anyone can download and access these data. There's rich metadata that accompanies them to make them machine readable, machine actionable. And not just that. The scientific record right now relies on a master key called the DOI system. The DOI system was state-of-the-art 35 years ago. It's based on the handle system. It's essentially a lookup table that says, here's the link from the publisher website, and here's the code, the DOI, with the prefix of the person who requested that DOI and a suffix which guarantees its uniqueness. That's all it is. With IPFS, with the content address web, we can do much better things. We now have the ability to create driftless, permanent identifiers. And that's something we didn't have before. And what does that mean? Right now, if I'm a scientist, if I want to save my work and get my research outputs out there in the community, well, I have to get a DOI for my paper. I have to get a DOI for my code. I have to get a DOI for my data. I have to start exploring all these web silos all around the world just in order to gather a collection of disconnected, permanent, persistent identifiers. This has to change, and we can make it change now. What you see here, every object in that research object has an IPFS-based CID that uniquely identifies it. And more than that, we have a syntax to make these objects citable, just like a file structure. Imagine if you could type in your IDE, import Desci or HTTP import in Python, for example, and then you could type import PID / my paper / version 1 / my data / measurements.csv. Now we can do this. Every research object is essentially a file structure with an immutable chain of PIDs that allow any objects contained within to be uniquely identified and citable so that scientists can gather credit with better UX because they no longer need to go around all of these web silos to gather these DOIs. And that's very important because that prevents artifact fragmentation. That also gives guarantee for long-term storage. What else do we have? Well, we have the ability to version these objects. That's very important. As we know, CIDs can't be, version, of course. Well, you need IPNS and these other things. But what we have here, we essentially create a system where you can version these research objects, and we take the root hash of that Merkle DAG, and we index it on a contract, on a blockchain. And the researcher has custody over the version of record. And he can upgrade, and he can version that PID, that research object, at will using token-gated versioning rights. So here we have the transaction record of that research object. It's on Gurley testnet in this time. We also have information about source. So this is rich metadata that we need to create. We can have funding information, contributors, all of those good things that we need to have in any type of scientific repository and publication platform. And finally, something we're very excited about, but it's very early as well. So I'll just give you music for the future. Associations out there have been trying to create alternative metrics of quality. Right now, the entire scientific record and the credit system works on prestigious citations. And there's very little information about, is the work replicated? You can't find that. You go on Google Scholar, you look for a paper. If there's a failure of replication, there's no way to find that without going through all of the objects that cite that specific work. We want to know if the data is being shared, if the artifacts are being shared, if the artifacts are reusable, if they're reproducible, if the work is replicable. So in this case, the ACM, the Association for Computing Machinery, has been making these badges that say, hey, the researcher has posted his artifacts. These are used in prestigious computer science conference already. But they remain on the conference website. It shouldn't be this way. They should be linked, tightly coupled in a verifiable data structure with your work. We can have artifacts are functional, it's been verified. Artifacts replicated. There's also organizations in Europe that are moving for fair data, findable, accessible, interoperable, reusable, like the GoFair Foundation. This is the idea that the richness of your metadata will allow machines and human to address, to crawl that work, to extract insights and to create more interoperability with these scientific data sets. So we can create alternative metrics, alternative systems to verify the quality of published research. And then the question, of course, arises, who verifies this? And this is something we've been dreaming about. It's the idea of decentralized scientific society that would replace the roles that journals play today, where scientists can reclaim the value of curating the scientific record for their communities. And they can reclaim that value and reinvest it into their communities, providing stipends to their PhD students who are woefully underpaid today, providing travel grants and opportunities, funding science projects. So in that particular example, we can say, hey, I would like these attributes to be verified. I would like peer review to be produced. Can select an autonomous research community, add a grant, a micro-validation grant. Anyone can do this. Anyone can directly and causally interact with the scientific record. How useful would this have been when this COVID paper came out saying that there was HIV insertions into the COVID virus on bioRxiv? How useful would it be to have an expeditive, hey, let's gather opinions of experts on this object. And by the way, we can gather it more than once with more than one community to have plurality of opinions in ways that return value to the scientific communities themselves. And that's something that could fundamentally change the landscape of science. And a few other things. We've also built citation schemas in a way that, for example, you can import the code of this paper in Python. We have a toolbox or a system that's similar to HTTP import. You can essentially type, hey, import Desci fetch, and you can import the code of that specific research object into your IDE. And what does that mean? All of a sudden, we have what Balaji Srinivasan calls citations as function calls. We can have that rich interoperability and reuse of artifacts. And we can measure all of this because all of this information is stored in a verifiable way once you publish that research object. And what does that mean? That means in the future, we might not need reference managers anymore, because we'll be able to back calculate and understand the credit graph of all the shoulders of giants that you're building upon. And these shoulders of giants shouldn't only be PDFs. should be code, should be data, should be these rich artifacts. And we should find ways to credit scientists for this. Of course, CIDs are not the most user-friendly links, as we all know. So it's also important to think about usability here. One of the things we've been working on is, hey, could we make persistent identifiers, our scheme, usable for humans in a way with short links? And so we've built, we have this in testnet right now, it's Desci. It's going to become DPIDs, decentralized persistent identifiers.org. So essentially you can take these long form, secure CIDs and shorten them with a contract and have that table that is secured on a blockchain, which now allows you to generate these super short links that are very, very sweet and very simple for humans to use. So, thank you. I want to make this a conversation. So I hope I'm going to have some questions, some comments. So please go ahead. Let's make this an interaction.
Hey, first of all, it's really great. Back in my research days, which is a long time ago, that was around when the web came around, I was thinking, we should all publish in HTML and interlink all the papers and stuff like this. Of course, never happened. So hopefully it happens this time. Right? Sort of one of the big barriers I see is just ego of the people involved in the scientific community, where they get to sit on the editorial board, the program committees, and there's quite a bit of crust in there. Do you see those issues, and if so, what do you do to break through?
Yeah, I mean the scientists are very conservative, right? This is the case, but they're also very smart. And if the technology is there that provides real benefits, for example, there are benefits that are absolutely undeniable with storage of large data sets, with the ability to compute on these data sets. If we can create an integrated stack that provides all of these perks that add value to their workflows, we can really, change habits there. And I think my other answer to this is that we've also started the Desci Foundation. So the Desci Foundation is a nonprofit in Geneva, and it's rallying fantastic meta scientists and scientists and great leaders in Web3, people that think deeply about the problems in science. And we need to be able to create a movement, right? We need to make it that it is for the people that want to publish verifiable research, that this becomes the credible place to do it. So that's very important. We need a movement of senior, experienced scientists that are respected by their communities to see the value and to bring this value in their communities. And it's also very important here, and this is also the power of Web3, which is often a little bit hard to communicate. How do we see this? Is this a platform that we control? No. This is essentially a system, a layered stack. We see the future as having an unstoppable repository that is accessible to all. And then anyone has the ability to spin a gateway on top of that. So it's not like we have this closed garden like you have right now in the web and cloud architecture. Anyone can spin up these gateways and interact with that ledger of record. And so we're really hoping that this combination of factor that we protect, we have built-in protection against the formation of data silos and monopolies. We have the ability to bring value with extremely cheap storage and compute. We have the ability to bring senior scientists, scientific leaders that bring value in their communities, to spread the word, and to create spectacular research objects on this system. These are the things we've been thinking about.
Oh, yeah, I mean, I'm totally buying the division, right? But really the question is, how do you drive adoption? How do you get people out of their, existing structures? So concrete measure would be, how many Nobel Prize winners you have, publishing on on the Desci platform, right? I mean, that might be sort of a good way to drive things forward.
Absolutely, absolutely.
I also have a couple of technical questions. So storing the data is probably fine, right? But if you say you also want to store the algorithm or the program with it, all that stuff is very much version dependent, right? I mean, lifetime of software is not very long, right? And how do you deal this in a if you really want to keep stuff around like for a long time?
That's an excellent question, and I'm hoping to find answers in this particular community. The way we think about it, hey, let's facilitate the use of containers and these types of technologies. But then again, they're not, they don't solve for all of this. And that's a very interesting question. How do we create essentially some guarantees around the lasting executionability of software? And I'm really curious to hear what your thoughts are about that.
Well, we had, with the legacy project, we had a similar problem, right? We don't have programs, right? But for us, it was how do you present this? And do you have you allow custom rendering or not? Right, and we said no, right? Because we thought, well, the rendering is going to change very quickly, and then somebody get to maintain all that custom renderings, and you will have, very very broken websites essentially. So we said no, we're not going to do that. We just store the artifacts and the semantics and so the metadata, and then there will be one for all rendering, and people can maybe do their proprietary rendering if they want to, but we would only support a single rendering, right? So basically we chicken out of the problem, right? Because we thought it would be too hard to maintain that, right? And so the thing would be, maybe in your case, to say, well, yeah, we store the data, but then sort of, maybe just describe the computation instead of have the actual program, the executable code sitting there.
Yeah, so having quality metadata around computations and steps that have been performed is a really interesting idea. I believe there's a lot of frontier applications of large language models in this regard. And you could even imagine situations in which you have automated annotation of programs that essentially perform types of computations that we know are not necessarily long-lasting. Because the big thing is we want to make the user experience as good as possible and as simple as possible. And for us, it's going to be a challenge to essentially query too much metadata out of the user, right? So if we want to have essentially the user describe, the computational steps that the user has taken to transform his data, that's a big burden on already overworked people, right? So one of the areas we're really interested in exploring with the Desci Foundation is this idea of automated annotation, right? And this could be a way to, let's say, finally achieve this kind of semantic web vision, because we can essentially automatically generate different types of metadata to enrich the searchability and the interoperability of these artifacts, and also increase their lifespan, right? So that's something we've been exploring, and we're really open to ideas and ways people are thinking about this in the computer science world, because I think it's quite fundamental, and it could go a long way in helping durability of code and processing pipeline and these things.
Another question I had, sorry, because I have the mic now, I'm giving it up. Identity. So you need to identify the author, right? And you said the author has the possibility to control version management and so on. That's probably we can talk about offline, because that's also super interesting to us. But how do you handle identity?
Yes, identity is a can of worms. So we can have a gradient of trust on our users. So that's the way we're thinking about it. So the thing that is we want to avoid as much as possible are things like identity spoofing. All right. So first of all, it's very important that we don't have any explicit incentive whatsoever in that system until we iron out these problems. The way we're thinking about identity right now is linking, essentially cross-linking other services that provide some durability and identity, like Gitcoin Passport, like Holonym. There's numbers of services that are there to essentially aggregate, user logins, like, well, log in with Gmail, confirm that, log in with GitHub, confirm that, log in with Twitter, log in with your institutional email. And at some point, you're establishing some trust that it's becoming harder and harder and harder to spoof that identity over the user. And if we do manage to establish, some sort of confidence around these user identities, that's going to go a long way. And it's a hard problem. It's also a hard problem from a UX point of view, right? Because it's, getting the user to actually go in these services and verify their identity. You need to have a very good reason to do this. So this is something we're struggling with, but I do think that there's some really interesting solutions on the horizon. So there's two big schools of thoughts. There's DIDs, verifiable credentials. There's also, SBTs. So there's interesting work in the space of essentially markers of reputation and attestations of identity. So we're trying to essentially find, what is the solution that imposes the lowest UX burden on the user and provides us with the highest bang for our bucks when it comes to creating a gradient of trust on that user.
Okay, and last question or comment. One of the things we're doing with our memoirs is that we basically create a semantic web out of it, right? So we're looking for all the interesting keywords in there, right? We should be things like events, people who occur in there, time, place, stuff like this, right? And then we basically create a semantic web graph all around that. So that's the first one. And recently I had was actually stimulated by a discussion earlier here in Lisbon. You could actually take that and so if you have the same, let's say the same event people write about, right? So you could actually compare them and say, well, there's so much overlap in the reflection of this event. And then you could also say, well, people disagree because memory is fading or they want to portray a different story or a picture of them or whatever, right? So, but I think there's really sort of interesting things you can do once you establish the semantic web. And I think there's even more richness in the type of publications you have. Is that something you've been thinking about?
Yeah, so other groups have been working on let's say, more semantic web-friendly systems like discourse graph, for example, where it's like a hypothesis, you have an answer to that, evidence accumulation, there's high-quality annotations around that, those knowledge objects, essentially, to make them really semantic web-friendly. So our approach is not to shock scientists too much out of their habits, if we can avoid it. And so our semantic web approach to this is essentially, well, what we want to have is machine actionable data, right? So we want to typically know what instrument was used to do your measurement. Take that from a control ontology, make that a controlled term and a controlled term from a vocabulary. And again, this is a UX pain, right? So right now there's no real good solutions out there to simplify the workload on the user for essentially, selecting those terms and selecting ontologies. And again, this is where we are really excited about machine learning, because we believe that the doorway to the semantic web, to this real vision, is going to be achieved by automated annotations from large language model on these digital artifacts. And then we don't need to make them human readable, right? It's all about machine readability. So you could have an enormous amount of keywords generated around an artifact, right? It's all fine because it's for the machine.
I was wondering if you'd looked at any citizen science projects and how that would fit into this paradigm.
Yeah, so we are building a community of people that are passionate about science. And one of the programs we're developing is the Node Stewards program, essentially finding people who love science, who are citizen scientists, who just nerd out on this amazing knowledge that's being produced by humans all the time, and that help us essentially outreach to scientists, find people with real problems. Hey, I have petabyte scale data. Hey, I have all these computational artifacts that my colleagues would love to use if only it was an API, right? And all of these questions to really kind of go out there and map out the space and find extraordinary research that we can create. We can build that as research objects, on behalf of the scientists with their consent, and really create these exemplary, beautiful, interactive research object. So it's kind of like a bottom-up community effort that we're hoping to spark, and in a way that also, honors and celebrates, good science and great scientists. Because I think, ultimately, scientists are the most undervalued creator class we have today, and that needs to change.
Hi. Some of my questions have been answered already, so thank you for that. and I've kind of forgotten a few of what I had as well. I think probably the first most practical one is speaking from a baccalaureate perspective now. So you have mentioned it in what you were discussing. Can you suggest, like, what's the biggest thing you're looking for from baccalaureate? How can we help you execute on what you're doing? And have you got a top thing? If we could do one thing, what would it be?
That's a great question. I want to make baccalaureate more palpable, more real. So one of the things I'm thinking is any data set you essentially upload as part of your research object, we should have a link to a baccalaureate playground, right? Where you can actually run minimal computation and be like, hey, it works, you know? Oh, this does something, right? And then have essentially that progressive funnel where scientists, they see the value without just going on the baccalaureate web page, you know, and like essentially having go through all that friction of interacting with the system for the first time, right? So one of the things that will really help us is we want to create, you know, these tremendous synergies. And there's really the beauty of like every CID you have in here is something you can operate with on baccalaureate. And when you think about it, that's absolutely amazing. And how do we make that value as palpable, as concrete as possible? That is really our challenge. So one of the things as well, we can make, you know, these notebooks, this VS Code integration, you know, have some sort of baccalaureate integration, although you don't have networking and server clients. So that's one part. But I think that perhaps the more actionable one is really about having like a playground we can link to or we can host on our site and just say, hey, click the link, baccalaureate, you have like a playground and you can run minimal commands and be like, whoa, this works, you know?
Yeah, it's a great idea. Thank you. And something a bit more related to your tech now. As for me now, I'm more of a user of science as opposed to a creator of it. So something that I'm quite active in reinforcement learning community, and something that I'm constantly having to do is to read the paper. Really cool. That's awesome. Who's implemented that? Because I'm not going to use their code because that's the academic code. And we're not going to, you know, we actually need, yes, flame war, sorry. You talked about citations, but do those citations kind of go in two ways? Can you sort of reach out to see, well, actually, this algorithm has been implemented in that framework because we've seen their link on their web page and it links back, you know, is that possible?
Yeah, so we're really interested in allowing these objects to aggregate a lot of links and a lot of code from different groups. So I think like the scientific cap table is a broken thing. We're not going to try and change that because that's too entrenched. But we essentially want to allow, you know, anyone to take this research object, press a button called fork, right? Just like a nice GitHub primitive, and be like, hey, I implemented that algorithm for production. It's here. You add it to that repo. You commit the research object. The person who has his node 4 gets a notification. Then they can merge it and be like, oh, this is actually really cool. You know, come in, right? Be part of that master branch. And that merge request essentially adds the person who added that value to the contributors of that object. Not the authors, the contributors, right? And that would be a way for authors to get these inbounds that are really interesting, where people are building things on top of what they're building, while also preserving that important consent loop, right? That idea that, well, you don't want to just, you know, be subject to let's say, you know, graffitis or pollutions on your paper, right?
I have a question about how you're integrating with other Desci projects. I think a useful, I write it down after, but like a sort of like a ecosystem graph. So you have, I guess you have like Holonym who are making sort of like decentralized identifiers for researchers. You also have like discourse graphs for that coming out of Protocol Labs research. How do you integrate with those solutions as well?
Yeah, so what we have is that we have interoperability at the contract level because every research object has a unique identifier. And what does that mean? That means now you can essentially link that unique identifier that's on a contract with any sort of other smart contracts that could happen, right? So you could have funding solutions. You could have, you know, integration with hypercerts. You could have integration with Gitcoin rounds. You can have all sorts of, you know, contract blockchain level integrations that can happen. That's something we're super excited about. But more broadly, the interaction with the Desci ecosystems is that, first of all, we are here to serve that ecosystem, right? It's very important for us that anyone can build on that stack and integrate that with their workflows, right? So what we want to do, for example, I mean, we can make, you know, longevity journals using Desci nodes. We can make all sorts, essentially, even people that are not deep in tech they still have the capabilities, to embed PIDs on their website to essentially create collections of research objects that don't require, some that are not too complex to integrate. So that's one way we're thinking about doing it. Another way is that this gateway, what we call this is like essentially gateway. It's all gonna be open source, and we want people to just own it and maybe brand it with their Desci project and their Desci community and customize it. We want to make it simple for people to do this, right? So that we all have these gateways that might be unique. Maybe there's a gateway for biology and it doesn't really care about some of these components, but it really cares a lot about videos of procedures. So that should be perhaps more central in the UI, right? So I think, science, there's no like really one size fits all. Every community has different requirements and different value props for what they get out of scientific publishing. And I think, we want to make it a modular stack that anyone in the Desci community, broadly speaking, can use. And the beautiful thing about that is every time research objects are created, it contributes to a common dataverse, right? It's not your silo, my silo. No, it's like our universe. I think that's a beautiful thing because we all start creating value for each other.
How can we design this in a way that makes it easy for people who are not scientific to be providing data? Because I think the data collection piece is really interesting, in particular ecological data. So I kind of think like the TaskRabbit, but for data, adding data into the system.
Yeah, so I think there's just probably two stages in data, right? There's the data collection stage, which might be done, by people on the ground. Then there's a data aggregation stage where you might aggregate the data from multiple collectors. And then there's the data annotation stage where you, as the person who's curating that data, you need to come up with like, well, what have you measured? In which context? What are your variables? If it's the type of formats, the types, right? Have it that important metadata component. And once you have that data set and that data annotation component, these can be combined and published as a research object for others to use. And the beauty about that is then these data sets become interoperable with Bacalhau, they become interoperable with all sorts of other Desci projects. So I wouldn't say this is a platform for, let's say, citizen scientists to collect data and to publish that data. I think it's more of a place you publish the data once it has reached, once it's well annotated, that it's really usable, from a formal scientific perspective. And that's really where the value, I think, is most manifest. And you can always append that data, right? So you could have, a year-to-year collection and just version that data set. And because we have that provenance trace and that versioning, we have all the prior versions as well, and it just keeps growing. And we have that nice, evolution of those data sets that could also, add quite a lot of value.
So, with the semantic linking, you could also, basically detect interesting correlations or overlaps between paper where people haven't been aware of that, right? Is that something people have explored yet?
So I think that specific part is more interesting on a data set like a general index, which is 120 million scientific papers that are all in n-grams that we're also going to be hosting as an API. OpenAlex is hosting this as an API, really fantastic data set. It's going to be a lot of the initial, spark for building up these models of automated annotations. And I think there's a tremendous amount of like really interesting things that can be had with these existing open source large data sets. Here, because we're starting, there's not going to have sufficient data volumes to extract insights at scale. What's going to be more interesting is doing things like, so for example, there's a classifier called the CSO classifier. There's an ontology of computer science, and it's really convenient. Because what you can do with that classifier is essentially you copy paste your abstract, or it just detects your abstract. You just extract it from the PDF, and you get metadata that's generated from a control ontology to annotate that PDF so that it's machine readable and more retrievable, right? So those are like the super interesting technologies we're very interested in. It's how to like really accelerate semantic web with AI classifiers, large language model, all of these things.